Dear students, welcome to my 5th class on module 3 Z transforms and difference equations. So in this lecture video we'll be discussing the problems based on the Z transforms. So the first problem is minus 3 power n plus 1 by 3 power n minus 7. Second one is 4 into 3 power n plus 2 into minus 1 power n. Third one is e power an. Fourth one is e power minus an. Fifth one is e power at. Sixth one is e power minus at plus t. Seventh one is a power n cos hyperbolic n theta. And eighth one is a power n sin hyperbolic n theta. Ninth one is r power n cos n theta. 10th one is r power n sin n theta. 11th problem is cos n theta. 12th one is sin n theta. 13th is cos n pi by 2. 14th is sin n pi by 2. 15th is cos square n pi by 2. And sin square n pi by 2. Cos cube n pi by 6. Sin cube n pi by 6. Cos of n pi by 2 plus pi by 4. And sin of n pi by 2 plus pi plus a. So now for all these functions I am going to find the Z transform with the help of basic Z transform formulas. So first one is find the Z transform of minus 3 power n plus 1 by 3 power n minus 7. The first thing is we'll be applying Z transform on both the sides, and to solve this problem I am going to make use of Z transform of one formula, that is Z by Z minus 1, and Z transform of a power n formula, that is Z by Z minus a, with the condition mod Z is greater than a. So first expanding this equation we'll be getting Z transform of minus 3 power n plus Z transform of 1 by 3 whole power n. The constant 7 I will take outside, into Z transform of 1 I will get. So here I am going to replace this Z transform of a power n formula. So in the place of a I will be replacing minus 3. So we got Z by Z minus of minus 3, and to simplify this I am going to replace a is equal to 1 by 3 in this formula. So we got Z by Z minus 1 by 3. Minus 7 I will keep as it is. So I am going to use this formula for Z transform of 1. So we got this equation. Therefore, Z transform of minus 3 power n plus 1 by 3 power n minus 7 will be equal to Z by Z plus 3 plus 3Z by 3Z minus 1 minus 7Z by Z minus 1 is the required solution. So next is Z transform of e power an. So we know that Z transform of a power n is given by actually what? Z by Z minus e. So in the place of a we have e power a now. So I'll be replacing a is equal to e power a. So we got Z transform of e power an is equal to Z transform of e power a whole power n. So this will be equal to Z by Z minus e power a. So same way like for Z transform of e power minus an also. So in the same formula I'll be replacing a is equal to e power minus a. So we got Z transform of e power minus an will be equal to Z by Z minus e power minus a. So next one is Z transform of a power n cos hyperbolic n theta. So here I am going to apply two formulas here. The first one is Z transform of an formula I am going to use, that is given by Z by Z minus a. One more is cos hyperbolic x formula, that is e power x plus e power minus x divided by 2. So now I am going to find the Z transform of a power n cos hyperbolic n theta. So I will keep Z transform of a power n as it is, expanding this cos hyperbolic n theta like this, that is e power n theta plus e power minus n theta divided by 2. So the constant 1 by 2 I will take outside. Z transform of a power n into e power n theta plus e power minus n theta, taking a power n inside the bracket, will be getting 1 by 2 into Z transform of a power n e power n theta plus a power n e power minus n theta. And by combining this we got 1 by 2 into Z transform of a e power theta whole power n plus a e power minus theta whole power n. So we got 1 by 2 into Z transform of a e power theta whole power n plus Z transform of a e power minus theta whole power n. So now to simplify this I am going to make use of this formula, that is Z by Z minus a formula I am going to use. So what will be getting? 1 by 2 Z by Z minus a into e power theta plus Z by Z minus a into e power minus theta. So take the Z outside. So we got Z by 2, 1 by Z minus a e power theta plus 1 by Z minus a e power minus a theta. Now taking LCM over there. So we got Z transform of a power n cos hyperbolic n theta is Z by 2 Z minus a e power minus theta plus Z minus a e power theta divided by Z square minus az e power theta minus az e power minus theta plus a square. So here simplify this, we got 2Z minus a into e power theta plus e power minus theta divided by Z square minus 2Z e power theta plus e power minus theta plus a square into Z by 2. So I'll keep Z by 2 as it is. So 2Z into, this will become 2 times of cos hyperbolic theta, we got 2a cos hyperbolic theta by z square minus 2az cos hyperbolic theta plus a square. So from this I will take 2 common factor and cancelling with 1 by 2, we got z transform of a power n cos hyperbolic n theta will be equal to z into z minus a cos hyperbolic theta divided by z square minus 2az cos hyperbolic theta plus a square. So in the same way we will be solving z transform of a power n sine hyperbolic n theta also. So same like a previous proof only, here in the place of sine hyperbolic n theta, I am going to apply this formula, that is sine hyperbolic x is equal to, will be getting e power x minus e power minus x by 2, so by 2. So now to expand this one, z transform of a power n sine hyperbolic n theta, in the place of sine hyperbolic n theta, I will be using this formula, that is a power n into e power n theta minus e power minus n theta divided by 2. This will be equal to 1 by 2 z transform of a power n e power n theta minus e power minus n theta. By taking a power n inside the bracket, I will be getting 1 by 2 z transform of a power n e power n theta minus a power n e power minus n theta. So on simplifying this further, we will be getting what? 1 by 2 into z transform of a e power theta whole power n minus a e power theta e power minus theta whole power n. So expanding this further, we will be getting 1 by 2 into z transform of a e power theta whole power n minus z transform of a e power minus theta whole power n. So now here I am going to use z transform of a power n formula, that is z by z minus a formula I am going to apply here. So what we got? 1 by 2 into z by z minus a e power theta minus z by z minus a e power minus theta. By taking z common factor, we got z by 2 into 1 by z minus a e power theta minus 1 by z minus a e power minus theta. So by taking LCM and simplify this equation, we got z by 2 into 2a sin hyperbolic theta divided by z square minus 2az cos hyperbolic theta plus a square. By taking 2 common factor, we can cancel 1 by 2. So we got z transform of a power n sin hyperbolic n theta will be equal to 2z sin hyperbolic theta divided by z square minus 2az cos hyperbolic theta plus a square is the required solution. So next one is z transform of r power n cos n theta and also z transform of r power n sin n theta. So here to simplify this one, I am going to make use of 2 formulas, that is z transform of a power n, it is given by z minus a, and e power I n theta formula. So e power I n theta will be cos n theta plus I sin n theta. So now I am going to find z transform of r e power I theta whole power n, and I am going to find both the values from this equation only. We will see how to find that. So now in this formula, in the z transform of a power n formula, in the place of a, I am going to replace r e power I theta. So what I will be getting? Z transform of r e power I theta whole power n will be equal to z by z minus r e power I theta. So it will be equal to what? Z transform of r power n e power I n theta will be equal to z by z minus r e power I theta. So this r power n I will keep as it is. Expanding e power I n theta as this one, that is cos n theta plus I sin n theta. So we got z transform of r power n cos n theta plus I into r power n sin n theta by taking r power n inside the bracket. So here I am going to expand this e power I theta in the same form only, that is cos theta plus I sin theta. So we got z by z minus r cos theta plus I sin theta. So simplifying this, we got z transform of r power n cos n theta plus I r power n sin n theta will be equal to z by z minus r cos theta minus I r sin theta. So now grouping all the terms. So here z transform of r power n cos n theta plus I z r power n sin n theta. So here z by z minus r cos theta minus I r sin theta. So now I am going to simplify this. So we got z by z minus r cos theta minus I r sin theta. So now into z minus r cos theta plus I r sin theta divided by z minus r cos theta plus I r sin theta. So by simplifying this, we got z into z minus r cos theta plus I r z sin theta. So divided by z minus r cos theta whole square plus r sin theta whole square. So now finally we got a equation like z transform of r power n cos n theta plus I into z transform of r power n sin n theta will be equal to z into z minus r cos theta plus I into r z sin theta divided by z square minus 2z r cos theta plus r square cos square theta plus r square sin square theta. So this will be equal to z into z minus r cos theta plus I into r z sin theta divided by z square minus 2z r cos theta plus r square. So expanding this further, we will be getting z transform of r power n cos n theta plus iz r power n sin n theta will be equal to z into z minus r cos theta by z square minus 2 z r cos theta plus r square plus I into rz sin theta divided by z square minus 2 zr cos theta plus r square. So now by comparing the equations, so by taking the real part, we got z transform of r power n cos theta is equal to z into z minus r cos theta divided by z square minus 2 zr cos theta plus r square, and z transform of r power n sin theta will be equal to rz sin theta divided by z square minus 2 zr cos theta plus r square is the required solution. So next one is z transform of cos n theta. So same thing here also, I am going to use the formula of z transform of a power n cos n theta. So this is given by z into z minus a cos theta divided by z square minus 2az cos theta plus a square. So now to find cos n theta, I am going to replace a is equal to 1 in this equation. So we will be getting z transform of cos n theta is equal to z into z minus cos theta divided by z square minus 2z cos theta plus 1. Similarly, z transform of sin n theta. So to find this one, I am going to use the formula of z transform of a power n sin n theta. This is given by az sin theta divided by z square minus 2az cos theta plus a square. So replace a is equal to 1 in this equation. We will be getting z transform of sin n theta is equal to z sin theta divided by z square minus 2z cos theta plus 1. So next one is z transform of cos n pi by 2. So same thing here also, the same z transform of a power n cos n theta formula I am going to use. So here I will be replacing a is equal to 1 and theta as pi by 2 in the same equation here. So I will be getting, if I replace a is equal to 1 and the angle as pi by 2 in this equation, I will be getting what? Z transform of cos n pi by 2. So this will be small z into z minus cos pi by 2 divided by z square minus 2z cos pi by 2 plus 1. So this will be equal to z square by z square plus 1 because cos pi by 2 is equal to 0. So next one is z transform of sin n pi by 2. So here to simplify this, the formula is z transform of a power n sin n theta is equal to az sin theta divided by z square minus 2az cos theta plus a square I am going to use. So here also I am going to replace a is equal to 1 and the angle as pi by 2 in this equation. So we got z transform of sin n pi by 2 is equal to z sin pi by 2 divided by z square minus 2z cos pi by 2 plus 1, and cos pi by 2 is 0 and sin pi by 2 is 1. So we got z by z square plus 1 is the required solution. So next one is z transform of cos square n pi by 2. So to solve this one, I am going to make use of cos square theta formula. Cos square theta is given by 1 plus cos 2 theta divided by 2. So now I am going to find cos square n pi by 2. So I am going to use this formula here, that is 1 plus cos 2 n pi by 2 divided by 2. So it will become 1 plus cos n pi by 2. So cos n pi is minus 1 power n. I got 1 plus minus 1 power n by 2. So now for this one I am going to apply z transform on both the sides. So z transform of cos square n pi by 2 will be equal to z transform of 1 plus minus 1 power n by z. So the constant 1 by 2 I will take outside. So into z transform of 1 plus minus 1 power n we can write. So expanding this equation, we got 1 by 2 into z transform of 1 plus z transform of minus 1 power n. So we got 1 by 2 into z by z minus 1 plus z by z plus 1. So by taking LCM, so we can write z by 2 into 1 by z minus 1 plus 1 by z plus 1. So take LCM over here. So we got z by 2 into z plus 1 plus z minus 1 divided by z square minus 1. So z by 2 into, we got 2z by z square minus 1. So here this 2 gets cancelled. We got z transform of cos square n pi by 2 is equal to z square minus by z square minus 1. So in the same way, we'll be finding the z transform of sine cube n pi by 6. So to find this, I'm going to use sine cube theta formula. So sine cube theta is 1 by 4 3 sin theta minus sine 3 theta. So now z transform of sine n theta will be z sin theta divided by z square minus 2z cos theta plus 1. So both the formulas I'm going to apply here. So first I'm going to replace this angle theta as n pi by 6 in this equation. So we got sine cube n pi by 6 is 1 by 3 sine n pi by 6 minus sine 3 n pi by 6. So by simplifying this, we got sine cube n pi by 6 is equal to 3 by 4 sine n pi by 6 minus 1 by 4 sine n pi by 6. So applying now z transform on both the sides, we got z transform of sine cube n pi by 6 is equal to 3 by 4 into z transform of sine n pi by 6 minus 1 by 4 into z transform of sine n pi by 2. So now to simplify this, I am going to use this formula. So we got 3 by 4 z transform of sine pi by 6 divided by z square minus 2z cos pi by 6 plus 1 minus 1 by 4 divided into z by z square plus 1. So on simplifying this, so we got 3 by 4 z into 1 by 2 divided by z square minus 2z root 3 by 2 plus 1 minus 1 by 4 z by z square plus 1. This is because of sine pi by 6 is 1 by 2 and cos is root 3 by 2. So on simplifying this further, we got z transform of sine cube n pi by 6 is equal to 3 by 8 z divided by z square minus root 3 z plus 1 minus 1 by 4 z by z square plus 1 is the required solution. So next one is z transform of cos n pi by 2 plus pi by 4. So here I am going to use two formulas here. The transform of cos n pi by 2 formula, that is given by z square plus 1, and z transform of sin n pi by 2 formula, that is z by z square plus 1. So now to expand cos n pi by 2 plus pi by 4, I am going to use cos of a plus b formula. So by expanding cos of a plus b, we got cos a cos b minus sin a sin b. So now for this equation, I am going to apply z transform. So what we will be getting, z transform of cos n pi by 2 plus pi by 4 will be 1 by root 2 into z transform of cos n pi by 2 minus sin n pi by 2. This 1 by root 2 because of cos from these two values it will become 1 by root 2. So we got so this equation now. So expanding this one, we got 1 by root 2 into z transform of cos n pi by 2 minus z transform of sin n pi by 2. So this is actually what z square by z square plus 1 minus z by z square plus 1. By taking LCM and simplifying this, we got z transform of cos n pi by 2 plus pi by 4 will be equal to z into z minus 1 divided by root 2 into z square plus 1 is the required solution. So next problem is find the z transform of the following equations. First one is 1 by n plus 1. Second one is n minus 2 by n into n plus 1. Third one is 1 by n plus 1 n plus 2. Fourth one is 2n plus 3 divided by n plus 1 n plus 2. And fifth one is 2n square plus 4n plus 3 divided by n plus 1 n plus 2. So now we will see how to solve this problem. So first one is I am going to find a z transform of 1 by n into n plus 1. So to solve this one, I am going to expand the equation 1 by n plus 1 in terms of partial fractions method. So I am taking 1 by n plus 1 as a by n plus b by n plus 1. So take LCM over here. We got 1 is equal to a into n plus 1 plus b into n. So replace n is equal to 0 to find the value of a. So we got 1 is equal to a plus 0. It implies a is equal to 1. Next replace n is equal to minus 1. We got b is equal to minus 1. So now replace this a and b value over here. So we got 1 by n into n plus 1 is equal to 1 by n minus 1 by n plus 1. Now applying z transform on both the sides, we got z transform of 1 by n plus 1 is equal to z transform of 1 by n minus z transform of 1 by n plus 1. So this is nothing but actually what log of z by z minus 1. This is z into log of z by z minus 1. By simplifying this, we got z transform of 1 by n into n plus 1 is equal to 1 minus z into log of z by z minus 1. Next problem, find a z transform of 2n plus 3 by n plus 1 into n plus 2. So same thing here also. First I will be expanding this 2n plus 3 by n plus 1 n plus 2 by using partial fractions method. So we got the equation like 2n plus 3 by n plus 1 n plus 2 is equal to a by n plus 1 plus b by n plus 2. So take LCM here. So now to find a, we have to make b 0. To find b, we have to make a 0. So I will be replacing n is equal to minus 1 in this equation. So we got a is equal to 1. And replace n is equal to minus 2 here. So we will be getting b is equal to 1. So now replace this a and b value in this equation. So we got 2n plus 3 by n plus 1 n plus 2 is equal to 1 by n plus 1 plus 1 by n plus 2. So applying z transforms now, we got z transform of fn is equal to z transform of 1 by n plus 1 plus z transform of 1 by n plus 2. This is nothing but z into log of z by z minus 1 plus z square into log of z by z minus 1 minus z. So on simplifying this further, we'll be getting the equation like z transform of 2n plus 3 by n plus 1 n plus 2 will be equal to z transform of z plus 1 into log of z by z minus 1 minus z is the required solution. Thank you.